Hello. So in this video, I'm going to discuss about a sequence detector to detect the sequence of 1001. So what I have observed, most of the students find difficulties to understand the concept of different sequence detector. So in this lecture, I am going to cover only one such type of sequence detector, that is Mealy overlapping method. Okay, you know, four methods are there: Mealy overlapping, Mealy non-overlapping, Moore overlapping, Moore non-overlapping. So four methods can be used to detect a particular sequence. So based on the question, whatever it is asked, we need to answer like that way. So in this lecture, I'm going to discuss about Mealy overlapping method. So using Mealy overlapping, we want to detect a sequence of 1001. Okay, we need to design a sequence detector which is going to detect a sequence of 1001. Okay, so I'll be using Mealy overlapping method. Okay, and this will be used to detect the sequence of 1001. This is the question given to us. Okay, now in order to design the sequence detector, the most important thing is to make the state diagram. If the state diagram is correct, then the rest of the things will be definitely correct. But generally students, what mistake they do, they uh, most of the times they cannot make the sequence detector, means they cannot make the uh, state diagram properly. And because of that, their sequence detector means answer whatever they get, it is also not correct. So we need to understand how to make the state diagram for a particular sequence. Okay. So in case of Mealy overlapping, we need to follow some rules. So the first rule is, if the sequence detector, whatever it is given to us, that is 1001, how many bits are there in the sequence? 4 bit. 4 bits are there. So how many states we need to consider in the state diagram? That is 4 states. Okay. So this is the first step what we need to follow. So the number of bits will decide the number of states in case of Mealy overlapping method. But if it is Moore overlapping, then the rule will be somewhat different. So for each of the method is having some different rules. So for Mealy overlapping, the number of states will be decided by the number of bits given in the sequence. Okay. So 4 states will be there. So we can write it down. State A, then B, then C, then D. These are the 4 states we are considering. Okay. Then we need to give the direction. There's a second rule you need to follow. And you need to give the sequence. This n minus 1 number of bit, blindly you can write it here one by one. So first is 1, the next bit is 0, then the next bit is 0. So if you have n number of bits in the sequence, for example, for this particular example, we have 4 number of bit. Okay, so n number of 1 number of bit, you can write it down one after another. So n number 1 means first 3 bit, you can write it down one after another in this line. So first bit is 1, second bit is 0, third bit is 0. Okay. Now after that, what you need to do, actually whatever value we have put here, these are nothing but the inputs from one state to other state. What input you are, means to go to one state to another state, what inputs you are providing, that only I've written. Okay. Now after that, what I need to do, I need to think about the remaining input, because for each of the state, how many inputs are possible? The possible inputs are 2, either 0 or 1. So we need to see which inputs we have already used and which need to be used. Okay. So for A to B, we have already used 1. So what still left for A? Left for A is 0. So I already told for each of the state, two inputs are possible. One is 1, the other one is 0. So for A to B, we have already used 1. The remaining is 0. So the remaining is 0 means what you need to do, sorry. So this will be a self loop. Okay. So as this is A is the first state, or we are considering this is the reset state. So for the other input, we need to again come back to our main state or reset state. Okay, this is the rule you need to follow. So for A, two inputs are possible. One is 1 we have already used. So if you use the input of 1, it means from A state to B state you are traveling. Now what is the remaining input? That is 0. So in case of 0, what you need to do? You need to again come back to your original reset state, that is A. So A is considered actually reset state. Reset state. Okay. Now think about B. Now uh, you need to follow other rules also. I'm telling one by one. Now for B, if you see here, B what it is detecting, it is nothing but it is detecting 1. The B state is nothing but it is detecting 1. So you can write 1 here. Now for C, what it is detecting? This is detecting 1 and then 0. Okay, C is detecting. So if you start from A, it is detecting A 1 and next it is detecting 0. So it means C is detecting 1 0. Now follow the same procedure for D. So what it is detecting? 1 0 0. So you write down the value 1 0 0. Okay. So these square box are not required. These are the things I am giving in order to make you understand how to make this the state diagram. So what we are doing, it is nothing but we are doing state diagram. I forgot to write this term, state diagram. We are making state diagram on it. Okay. So this is very much important to understand the state diagram. That's why I have written this thing. Though the square box are not required to make the state diagram, for your understanding purpose only, I have drawn the square box. Okay. Now we can go to our next step. So for A, we have considered both the possible input 1 and 0. Now for B, we need to do the same procedure. Now for B, what we have already used, 0 input we have already used. So for B, if we use 0 input means we are going to C state. Now what input still left? What we need to consider? 1 we need to consider, because I already told for each of the state you need to consider two input, 0 and 1. So for B we have already considered 0. What still left? 1 still left. So we need to find out for 1 what we need to do. So actually what procedure you need to follow? In the square box, what 1 you have written, that you have to copy here, copy paste here. Okay. And for B, whatever the remaining state is left, means whatever the, sorry, not remaining state, whatever the remaining input was not considered, that you need to write in the right side. So what input is not considered for B? One input is not considered for B. So you need to write in the right side. Understood? Again, I am saying for B, what you have already used 0. What you didn't use 1. So that 1 only I have written here. Now what you need to do? You have to make a comparison between this square box 1 and this remaining input 1. If they are same, then you need to use the self loop. Okay. The input is 1. Okay. If they are same, you need to use the self loop. If they are not same, you need to go to reset state. Means you need to go to A. Okay. So in this case, we have seen this 1 and this 1 are same. So we need to use the self loop. Okay. Now come to the next one. Come to the state number C. So for C, what we have already considered, 0 we have already considered. What still left? 1 still left. Okay. So for 1, we need to find out in which state we need to go. Now how to do the this process? So in the square box, whatever it is written, you just copy paste here what we have followed in this state. Same thing you need to follow. This 1 0 I have copy paste here. Now what you need to do? Whatever the remaining input you didn't consider for C, that you need to write here. So C I have already considered 0. What still left? 1. 1 still left. So I have written 1 in the right side. Now after that, what you need to do? You need to compare this square box 2 bits with these 2 bits, right side 2 bit. Okay. How I have generated 2 bit? First of all, I made this thing copy. Then whatever the remaining input I didn't consider for C, that I have written in the right side. And this right side 2 bit I have taken. Now what you need to do? These 2 bits you need to compare to the right side 2 bit. Are they same? No. If it is not same, then you need to take the last bit, extreme right side bit. Okay. And extreme right side bit is a single bit, means you need to compare with the single bit state. What is the single bit state? That is 1. So you need to compare this one with 1. So 1 1 means both are same, means you need to go to that state. Okay. Now the question is, suppose these things were same. This is 1 0 you have got in this box, and suppose these 2 bits were also 1 0. Then in that case, what you had to do? You had to make a self loop. If these states are same, if these two things are same, then you have to do the self loop. If they are not same, then you take extreme right side bit. As it is 2 bit, then you need to take 1 bit. That is the right hand side bit, that is 1, and that one you need to compare with this one. This 1 bit state, if they are same, you have to go to that state. If they are not same, you need to go to reset state. This is the rule you need to follow. Now, what about D? So for D, you have to follow a different rule. Why? Because up to C, you had one input, but for D, for D state, you didn't consider any input. You didn't consider 0, you didn't consider 1. So in case of Mealy overlapping method, up to n minus 1 number of state, you need to follow these rules. And when you are coming to the n state, that is the last state, in that case, you need to follow some different rule. Okay, what rule you need to follow? Why you are following two different rule in this case for the last node or for the last state? Because in this state, you didn't consider any input. You didn't consider 1, you didn't consider 0. So you need to consider both the things here now at the same time. So what are the things you need to consider? Your input can be 0, your input can be 1. So as it is a single bit comparison you are doing, means you have either 0, you have either input 1. So you need to compare with the single bit state. Okay. So 0 with 1, are they matching? So let me write it down. So first compare this 0 with the single bit state. Single bit state is nothing but 1. Are they matching? No. So no means you need to go to reset state. I already told you, if there is mismatch, you need to go to reset state. Okay, when you have considered the input of 0. Now what about the other one? The other one is 1. So 1 you need to compare with the 1 bit state. Are they matching? Yes. So you need to go to the 1 bit state, that is here. Okay, when your input is 1. Understood? So all the inputs we have considered. Now we need to check the output. Okay. Now start from the first state, A state. So A is having self loop. You have given the input of 0. So what does it mean? 0 means has it detected 1001? No. So output is 0. Now come to B state. From A to B, what is the input you have applied? 1. So 1. Is it detected the entire combination 10001? No. So output is 0. Now for B self loop, what it has detected? 1 and 1. Is it the sequence what we want? No. So the output is 0. Now come to state C. What it is detecting? 1 0. Is it the sequence what we want? No. So the output is 0. Now come to state D. What it is detecting? 1 0 0. Is it the sequence we want? No. The output is 0. Now come to this one input. So what it is detecting? 1 0 0 1. Do you want the sequence? Yes, this is the question only asked. 1 0 0 1 you need to detect. So it means that the output will be 1. Why? Again, I am saying why I have considered here 1, because the detected sequence is 1 0 0 1 1 0 0 1. You make some sort of this type of loop. Now see 1 0 0 1. So it means that it has detected the sequence of 1 0 0 1. That's why I have written the output of 1. Now come to this 0 input. What it is detecting? 1 0 0 0. Is it the sequence what we want? No, that's why the output is 0. Okay, so ultimately, this is our state diagram. We have completed the entire state diagram part. Now, very easily you can do the process. Okay, as we have our state diagram, so very easily we can do the process. Now I'll remove the remaining part. Otherwise, it is looking more clumsy, so I can remove the remaining part. Whatever extra things I have considered. So you have done the state diagram. Now, what you need to do? You need to make state table, the third step. State table you need to make. Okay, how to make the state table? So, okay, let me use less space. I need to compare each of the thing. State table. State table. Okay, so what I need to do? In state table, I need to write down the present state, then input, then next state, then output. Okay, this is the table I need to make first. Okay, so what is the present state? You have the present state A. So we have to consider each of the state twice. Why? I will tell you. So A you need to consider twice. B you need to consider twice. Each of the state you need to consider two times. C you need to consider two times. D you need to consider two times. Now the question is why? Because in each of the case you can have the input of 0, you can have the input of 1. You can have the input of 0, 1, 0, 1, 0, 1. Okay, now see this state diagram. If you are in A state, if the input is 0, if you are in A state, if the input is 0, which state what will be your next state? It's nothing but your next state is again A. Understood? Because it is talking about this self loop. You are in A state, your input is 0, and you are again coming to A state as self loop is there. Okay. And at that time, what is the output? That is the output 0. So you have to be very careful. This type of symbol, whatever it is given in the left side, that is input. And whatever given in the right side, that is output. Okay, in this slash sign, whatever it is given in the left side, that is input. Whatever it is given in the right side, that is your output. Okay. Now check for one input. So you are in state number A. If the input is 1, where you are going? You are going to state number B. At that time, what is the output? It is 0 on B. This output is 0. Now for B, same thing you follow. For B, if the input is 1, you have the self loop, means for input 1, you have the self loop B and the output is 0. By default, you can write. And if the input is 0, for B, if the input is 0, then where you are going? You are going to C. And the output is also 0. Now for C, if the input is 0, where you are going? You are going to D. And for C, if the input is 1, where you are going? You are going to be okay. For that one, I didn't write the output. The output will be 0. Okay. Because what it is detecting 1, 0, 1 for this loop. 1, 0, 1 means we didn't get the sequence whatever we want. So that's why output is 0. Okay, fine. Now, what I have written from C, if you have the input of 0, you are going to D. And from C, if you have the input of 1, you are going to B. So write down B, and both the case, the outputs are 0. Now, do the next part. For D, if the input is 0, for D, if the input is 0, if you can remember where you are going, if for D, if your input is 0, where you are going to A state. So write it down. Okay. Now for D, if the input is 1, where you are going to B. And at that time, now output is 1. You can remember here the output was 1 I got. And for the previous one, output is 0. So state table almost we have made. Now from here, we need to consider different values. So how many states are there in this particular problem? 4 states are there. A, B, C, D. So if you have 4 states, how many bits are required to represent each of the state? It is nothing but 2 bit. So A will be represented by 0, 0, B is represented by 1, 0, 0, 1, C is represented by 1, 0, D is represented by 1, 1. As you have 4 states, you need to consider 2 bit for each of the state. If it is 8 state, then you had to consider 3 bit for each of the state. Okay, this simple 2 to the power n rule. Okay, and the number of state, and this will be deciding the number of bits. So as you have 4 states, you have to consider 2 number of bits. The n value will be nothing but 2 in this case. Okay. Now replace the A, B, C, D value by this 0, 0, 0, 1, 1, 0, 1 combination. So I'll write it here, the next page. So present state you have, then you have next input, sorry. Okay, I'm considering X as my input. Then you have next state. Then you have output. So I'm considering Z as my output. And I shall use JK flip-flop to implement this circuit. Okay. So I can write it down Q1, Q0. And next state is Q1. Okay. So Q1 dash, Q0 dash, I'm writing as the next state. So I'm replacing the value of A, B, C, D, whatever I have found out in this table. I have to just replace this A by 0, 0, A by 0, 0, B by 0, 1, C by 1, 0, and same thing I need to follow for these values also. So I'm writing it here. And as you have 2 bits, okay, how many flip-flops will be required? 2 flip-flops will be required. Okay. If the number of bits are 2, 2 flip-flops will be required. So for this problem, I'm using JK flip-flop. So how many flip-flops will be required? As 2 bits are there, 2 JK flip-flops will be required. So suppose the first flip-flop is J1, K1, and the second flip-flop is J0, K0. That I'll find out. Okay. So I'm replacing the value of A and B here. 0, 0. Then if you can remember, second one was 0, 1, 0, 1. Third one was 1, 0, 1, 0. Fourth one was 1, 1, 1. And at the time input was 0, 1, 0, 1, 0, 1, 0, 1. And from here you had A means 0, 0. Here you had B means 0, 1. So I'm replacing the value only. You can check the values. Okay. Then the output values were this. And last one was 1. Now what you need to do? You need to use the concept of excitation table of JK flip-flop, and you need to find out the value of J and K for each of the case. So what was the excitation table? Can you remember? If you have the present state, if you have the next state, suppose if your present state is Q and next state is Qn plus 1, what should be the value of J and K? That is your excitation table. So if you have 0, 0, 0, 1, 1, 0, 1, 1. These are the 4 combination for 0, 0, 0x, 1, 0, 1, 1x, 1, 0, 1, 1, x 0. That was the excitation table of JK flip-flop. Now you need to use this excitation table to get the value of J and K. Okay. Now, so you find out the excitation table. Okay, how? So compare this 0 with this 0. 0, 0 means you need to write 0x. Then compare these two. 0, 0 means 0x. So likewise, you need to follow the same procedure for all the things. This will be 1x, 0x, x0, x1, x1, x1. Now same procedure you need to follow for the next bit, this 0 with this 0. So you'll get the value of the second flip-flop, that is 0x. With this one, 0, 1 means 1 x. Okay, and then x1. So I'm writing it down all the values. So x1. Then same thing you need to follow for this bit, this bit. So it will be x0. I'm writing it down all the values. 1x, 1x, x1, x0. Okay. So our table is ready. Now what we need to do? So we need to use these three things. What are the three things? Q1, Q0, and X. This will be considered as our three input variables, and we need to find out five things. Z value, J1, K1, J0, K0 using KMM. So how many KMM should be there? 5 KMM. One for Z, one for J1, one for K1, one for J0, one for K0. 5 KMMs you need to consider. And for each of the KMF, what input variable you need to consider? It is Q1, Q0, and X. So if you make the KMF, suppose I am showing for the first one. So my input is Q1, Q0, and the third then third variable is input X I'm considering. So the variables 0, 1, 0, 0, 0, 1, 1, 1, 0. So I'm putting the value, suppose for example, I'm putting the value of J1. Okay, I want to get the value of J1. So the J1 values, I'll write it here. This J1 is 0, then 0, then 1, then 0, then X, then X, X, then X. Okay. So what we can do, we can make a pair and we can get the value of J1 equal to Q0 X bar. Okay. Now, likewise, we can find out the value of. So I'm showing for K1 also, remaining value I'll directly write down. You can easily find out the values. So 0, 1, 0, 0, 0, 1, 1, 0. So for K, you check what are the values. You got K1 actually. Is don't care, don't care, don't care, don't care. 0, 1, 1, 1. So what you can do, you can make this word. So for that, what you will get? That is Q0, and we can make this word, and what you will get for this one? Get X. So if you follow the same procedure for all the variables, this KMF if we make, then for J0 we'll get the expression of Q1 plus X. For K0 we'll get the expression of X bar. For Z, this output Z also we have to find out. If we put in the KMF, what we will get? That is Q0, Q1, and X. So you have got all the expression. Now we need to make the circuit. So how many flip-flops you need to use? We have already found out two flip-flops are there, J1, K1, and J0, K0. There's J1, K1, Q1, Q1 bar. And for the second one also, this J0, K0, Q0, Q0 bar. Okay. Then what we got? We need to find out. So J1 we got as Q0 X bar. We can take another input X also here. But the thing is that if we make all the connection like this way, how it is given Q0, so you have to take one line from this Q0 terminal and we have to give in the input. So the circuit will be so much complicated, it will be clumsy only. So in order to handle this problem, directly I'll give the input here. And so J1 is having the value of Q0 X bar. So write it down. And this is AND relation actually. Q0 and X bar. Directly I'm writing. So ideally, what you have to do, you have to take a line from this X input, you have to use a NOT gate, then you have to give it to here, and Q, you have to Q0, you have to collect from this terminal. But if you do like this way, then so many connections will be there. So it will be hard to understand how the connections are made. So it is better directly you write the values here. Okay. This is not a problem. Now for K1, what we got? K1, we got Q0 plus X. So we have to use some OR gate. One of the input is Q0, another input is X. Okay. Now for J0, what we got? Q1 plus X. So write it down. one OR gate you need to use. One of the input is Q1, sorry, not Q0. The input is Q1 and another input is X. And for K, what was the value you got? X bar. So write down K is your X bar. Okay, fine. Then what you need to do? Z. Z is Q0, Q1 and X. So you can take Q1 from here and Q0 from here. So you can take one of the line from here. Okay, another line from here and other line from X because you had Z equal to Q0, Q1 and X means you have to use 1 and 8 and that is your Z output. This is nothing but your output. Okay, so Z is Q1, then Q0 and X and AND relation. Okay. So you almost completed the entire circuit. One thing is left. We have not given the clock. That is very much important. This clock. This is the clock. Some clock. This is the CLK. Okay. So this is the implementation of your sequence detector, which will detect the sequence of 1001 using Mealy overlapping method where JK flip flop was used. So thank you very much.